Hello and welcome to the Parenting Truth and Dare podcast. I'm your host Ritika Subhash, and today I have a very, very special guest with me. In fact, someone who I consider my mentor, and he is a wonderful resource to talk to, especially for educators. But today we are going to be talking to Professor Pant here for children, for parents. So, a brief introduction of Professor Pant. He got his PhD in computational physics from IIT Roorkee. He has been a faculty for about a decade at the IIT Kanpur and a member of the board of management at IIT Delhi for 6 years. He's been a pro vice chancellor at the IGNOU University and faculty at IIT Kanpur, MLNR Engineering College, Allahabad, and visiting faculty at the University of Western Ontario, Canada. His current interests are cognition, AI in education, and creating awareness of quantum technologies. He's a very prolific speaker, as you will hear today, and he has been at several TEDx events. Welcome, sir. It is our honor to have you
Thank you.
Truth and Dare podcast. So today we are talking about a topic which is very close to your heart and also something which I'm getting intimately involved in through you, which is quantum science. So my first question to you is, why is quantum so important to learn?
And the simple answer is because that is the way the world is.
Mhm.
So at a very basic level, the world is quantum in nature. And to elaborate on that, you trace the history of growth of knowledge and understanding of the world, etc., from, say, thousands of years, from the Greek to including our own thing. We said the sansar panch tattva se bana hua hai. So since then, we've been trying to understand what the universe is about. So 5 elements is probably in Greek mythology, in our tradition, etc. Then we come fast forward to recent times. Everybody who's educated in school level knows something called the periodic table in chemistry. The periodic table is a list of all the elements that we have. So actually, Panchatattva is one thing, but the 120 odd elements is all that we have in the world. Everything is made out of these elements. And that was done by Mendeleev, and we all study that, and that periodic table has helped a lot in understanding of the world of elements and so on and so forth. But people continue to look at more fundamental things, and you heard about Democritus and so on and so forth. Beginning of this century, last century, people started looking at the structure of the atom itself. And the first thing they were able to find out as a particle was called the electron. Then they found something called the proton, then something called the neutron. And if you look at it, from the entire periodic table is just talking about how many protons are there, how many neutrons are there, how many electrons are there, and in which orbit are there. That gives us the properties, whether it's an acid, base, salt, whatever, and so on and so forth. So this is the state of knowledge that was there. At the beginning of this century, 1905, 1907, etc., the people who were exploring this, and we'll call them scientists and physicists, started figuring out that there are even smaller particles. And not only particles, even energy is not continuous, but is in certain discrete units, which are called quantum. And quanta was the word from the German thing, and it was called quanta. We'll get more into it as we go across. But the point is, today, once you get to the stage, many people will be shocked, and I try to talk to doctors these days about saying that quantum physics is your invisible ally in 21st century medicine. So Schrodinger, who's so well known for having talked about the quantum phenomenon and the wave equation, he wrote a book in 1940 or so. In fact, it was a series of lectures he gave at Dublin, which became a book called What is Life? And he was looking at quantum to explain life. And he sort of created this concept of a replicating thing in all living systems, which Crick and Watson later on agreed that that is where they got the idea of the DNA, and they then found the structure of the DNA and won the Nobel Prize for that. So to respond to your question, quantum cuts across the animate world, the inanimate world, and life itself. only now people are starting to appreciate quantum biology. And there is a person called Jim Al-Khalili. He is a great one on popularizing quantum biology. You can read his book or see his videos. Did you know that many of these birds which fly transcontinentally are doing it based on the principle of quantum entanglement? They have
Wow.
no base station, no the station, etc. to tell them. And all of these from Europe, when it gets cold, they come down to the temperate region and so on, almost thousands of miles
Yeah.
with quantum entanglement with the things is the thing. Photosynthesis is a quantum phenomena. Perfumes that you smell and distinguish are because of their quantum vibration frequencies of their modes and so on and so forth. And enzymes that we have, and I won't go here, but to me, when you look at phenomena like aging and cancer and many diseases, their root cause is quantum tunneling in particular. So this is why it is something which, as I said, is the thing which puts that across everywhere.
Yeah.
And long ago, Plato had said in his academy, there was supposed to be an inscription that no one ignorant of geometry enter. Similarly, in the future, let no one ignorant of quantum mechanics will be able to be part of the people who are knowledgeable. See, you can be part of the knowledge society or you can be part of the ignorance society. You want to be part of the knowledge society and you want to describe the world as it is or try to appreciate the world or even various phenomena. Quantum is the essential part. We'll go more into it as further questions arise.
Absolutely. So this actually brings this question to mind, that why was this not taught more large scale? Why was this not discussed before, let's say, 5 to 10 years ago? What was the reason that we studied of phenomena, or we taught our children of phenomena, like, let's say, like photosynthesis, but we never talked about, or nobody even asked the question, what is happening at the very minutest level to make this happen? So is it that the right questions were not getting asked, or the answers were only revealed very recently? Can you throw some light on that?
Yeah. No. I can tell you very simply. You see, the idea in India, and people may not like it, but in India, idea we were not keen to share knowledge or spread knowledge. The Indian tradition is not about sharing knowledge, but about holding knowledge, preserving knowledge, not telling. I mean, you are a woman. You were not even allowed to hear Gayatri Mantra. Right? Now, this is our age-old tradition month, supposed to be the pinnacle of wisdom and knowledge, but women were not supposed to hear it. Even children, I remember when I was young, so my Janevar Upanayan was not happening, but my elder brother was happening. So he would get to hear the Gayatri Mantra at the ceremony. I wouldn't. So I read it in a book and learnt it. So this is the point. So we would not, India is not about sharing knowledge. And specifically that you said, what happens is our school curriculum, problem is that when you say, let us, even today, I know I talk to a lot of even physics teachers, but they say, even we don't understand quantum physics, how will we teach? So the problem is, we are going by the ability of people to teach rather than the need of students to learn. And I am sure you would be aware because you take an interest in maths. In India, there was a time long ago, maybe 50 years ago, 60 years ago, where Professor J.N. Kapoor of IIT Kanpur and some others led a movement for what was called modern mathematics. So they were trying to teach people set theory, etc., etc., and it was opposed by everybody. More recently, a couple of decades ago, NCRT had a director called Dr. Parveen Sinclair. She was a mathematician. She was in TIFR. She was also in IGNOU, and therefore I know of her personally. She tried to introduce something modern in mathematics in school. They didn't allow CBSE. So in all NCRT textbooks, there are two things called Appendix 1, Appendix 2, which is talking about mathematical methods and proof and so on and so forth. But CBSE says you don't have to worry about this to pass the exam.
Yeah.
The point is, so the point is, we don't want to prepare people for what is needed. And also, I have no hesitation. I'm a bit cynical. I think the government enjoys the idea that the population is ignorant. That, you see, once they become science oriented, thinking oriented, they will start asking so many questions. For them, maybe this person may not appear to be the wisest person, all-knowing person, etc. So they may start applying their own thinking. So government has a vested interest in seeing that most people remain uneducated, uninformed, and apart from subject matter, the general ability of critical thinking, reading, etc., is not there. Why so much emphasis on what is going to be put in NCRT books? Because you think most people will not be able to read anything beyond NCRT books. Otherwise, why should you worry about what's in NCRT books? NCRT books may have their own thing. There may be many other things, but they're so much worried because they know that their people they are creating will not read anything other than NCRT books.
Yeah.
So this is the reason. And the also what has happened is the information age and the internet has come up suddenly upon educators. They still are not aware how to deal with internet, how to deal with chat GPT, how to deal with AI, etc. So
Yeah.
their whole model. So I have no hesitation that when I was at the MSc level in physics, we were the only people who could understand what is laser, light amplification through stimulated emission of radiation. Today, every other person is doing laser surgery if he's got cataract, he or she has got cataract, or sometimes for skin issues, sometimes for this thing, and femtosecond laser is like routine vocabulary.
Yeah.
But there was no way anybody doing less than MSc physics could have known what laser is. And actually, historically, laser came later. First, lasers came, which are called microwave amplification through stimulated emission of radiation. So the idea was that things which are difficult, instead of simplifying access to it and making it available to people in simple, usable terms, we want to make it more and more difficult. You have to pass an IIT JEE entrance test before you can get into hearing what it is.
So this is a very fundamental problem, right? And we have seen, at least in the last 2-3 years, that the more open the knowledge is, the better it is for everyone. And I think there are now many new initiatives in terms of MOOCs that are available where children, adults, continuous learning can happen. A lot of it has changed, I would say, because I've also been in the education sector for the last 12 years. So the access to information is now there. Now coming to the question as to where to access this information, how should children, parents upskill themselves, understand more about quantum? Let's assume that it is not going to come into the CBSE or the NCRT framework in the next 10 years. Let's assume that.
Yes. Very good.
We won't go into the reasons why it won't, but let's understand what we can do about it.
Exactly. So you're absolutely right. Now today, for example, while we are saying schools, college, universities don't teach it, the amount of resources available are enormous. And there are now well-known people who are very good communicators and great physicists as well. And they are available as videos on YouTube. And not only YouTube long videos, you know, short videos, not exactly TikTok, but short videos. Now, one of the greatest people in this field was Carl Sagan. Carl Sagan brought cosmos to the entire world, and it's available for free today. There are books available. There are, in fact, I have a very favorite person who's actually done these books for children.
Wow.
Chris Ferry.
Okay.
And the reason he did this was, he said, we create stories for children, telling them about elephants and tigers and jackals and so on. Where will they see that? But they're seeing around themselves all this technology. Why are we not telling them about it? So
what's the name of
one of my favorite things.
What's the author?
Chris Ferry.
Chris Ferry, okay.
Chris Ferry. Yeah. But you can Google for this thing. And I have been notorious that in my extended family, my nephews and nieces have all got books like Quantum Computing for Babies, Quantum Information for Babies, this, that. So, and there are board books. And then after 8 or 10 pages, now you have become a quantum scientist, whatever. So it is there. There's another very interesting person, I think Chad Orswell. You can go. He has a very nice book called Teaching Quantum Mechanics to Your Dog.
Oh, goodness.
So he has the dog and he tells and he teaches the dog quantum tunneling, everything, and so on and so forth. So there are a lot of people who do that, and including the original people. So the point is that there are two things. One, you must be curious and interested. So that is the first thing. The second thing is, today you can Google and chat GPT. So many of the questions that you are asking, you just ask chat GPT. It will tell you exact details, etc. And you can have a conversation with chat GPT. So when you ask chat GPT, it's a Chris Ferry, etc. It's okay. So what is the book by Chris Ferry? Where can I get that book? And sometimes you can go straight to Amazon and write Chris Ferry books for children, and it will give you all the kind of a thing. In fact, he calls it, I think, Baby University or some such thing. So where is this thing? So the point is exactly this, that do you want? The other problem is that, and this is my personal perspective, many people in India have seen that being better educated gives you better status, position, money, and everything. The point, therefore, is they have now inverted the logic to say, unless there is money coming from it, I won't learn. So, broadly, if you will look at, the more educated a person is, the better he off is in economic terms. What has happened is they've perverted the logic to say, I will learn only something if there is more money. I mean, you must have seen an IT thing, if I learn this, what will my package be? If I learn this, what will my package be? If I learn this, what will my package be? So, this is a kind of pervert mentality that has happened. But if they say, I want to learn this because I don't understand, and I want to share that there's a very interesting story. Max Planck, for example, was a German physicist, and when he was doing this physics, his professor, and he's also German, well-known professor, said, there is nothing new to do in physics now. We have understood everything. Newton, Maxwell, this, that is all that. There is nothing new to do in physics. And I like that answer which Max Planck gave. He said, I don't care if I can do nothing new in physics. I want to understand what physics is. And he created all this, that led to this new thing of quantum mechanics and so on and so forth, or Planck's constant is named after him, etc. So I think our approach should be that I want to learn what's going on. Why is this thing happening? In my understanding model, it doesn't happen. It is not enough to say it just happens. Or in colloquial, rab di maya hai. That won't do. So you have to be able to understand. So when you start wanting, so you want to have as you said, photosynthesis, when you teach children, why don't they ever ask that how does this happen? You say CO2 plus this thing gives you CO2. What happens? Where is from the light this thing happening?
No, so again, it comes back to the fact that with so much curiosity, you need time with the educator to be able to quell that curiosity in terms of, giving the right answer, being patient, all of that.
So the role of the educator is to help ask questions. To me, the role of the educator is not so much giving the answers, but triggering the right questions. And I will share with you, for example, I've been sharing this, I've not shared with large number of public. You know what photosynthesis is? Plants can do photosynthesis. Why can't we do photosynthesis? If we could do photosynthesis, ये फार्मिंग, एग्री, पोल्ट्री, ये सब करने की जरूरत नहीं पड़ेगी. एंड हम सब लोग वेजिटेरियन हो जाएंगे, कोई जानवर नहीं मारेंगे, कोई प्लांट को भी नहीं मारेंगे. और हमारा स्किन सनलाइट से विटामिन डी तो बनाता ही है ना. तो थोड़ा ट्रेन करना है कि विटामिन डी बना दो, ग्लूकोज भी बना दो.
ऐसा टाइम आ सकता है बिल्कुल, and I think that will solve the world's hunger problem, the world's obesity problem. I think a lot of related problems.
And the beauty is, even if you don't get your skin to do it, you can create some material which will do it.
Exactly, a chip to do it.
And you can wear it. So you are self-sufficient in food. You're wearing this thing. So your skin may not be able to do it. Let us say there's some biological limitation. But the advantage of quantum is that once you understand things at the quantum level, you can make that happen. And make that happen because some barrier is too high, you can make it lower, etc., and so on. So now you have some idea why this is such an exciting field. And why I am excited about it. I told this to some people. See, this is perfectly doable, right?
It is doable. It is possible, of course, and maybe sooner than we think. Especially in fields like medicine.
Exactly. So that is why I want the younger people to be aware of it.
Yeah.
Because they don't have any barriers.
Yeah.
Once they realize that ये करना है उसमें है तो इसमें क्यों नहीं हो रहा है, we'll figure out and they'll come up with some way of doing it. For adults, the problem is we always filter by practicability. Is this doable? Is this not doable? Etc. Can it be done? Who has done it before? And so on. Whereas children, because of their imagination, will move to stuff. So children's imagination plus adults' experience and knowledge is what is going to give rise to these solutions.
So, very interesting point you brought there in terms of children's curiosity, their natural ability to be in that state of curiosity, right? And as parents, many of us, I am not putting names or blames, but I'm saying we are all hard pressed for time. So sometimes we end up squashing that curiosity. Now, the other thing which happens with parents, and because we are on the Parenting Truth and Dare podcast, I have to ask you this, is that many parents will understand, okay, quantum technology, it's the understanding of the basic unit of life, right? Let's put it that way. Life
of
or
the world.
Of the world,
Of
life
the
or
world,
non-living.
living
Yes.
and non-living. Yes.
Living and non-living. So maybe
Yes.
they can understand and they can fathom that, yes, tomorrow this will be the basis of all sciences, new inventions, developments in medicine, in aerospace engineering, lots of different things. So they understand its importance. Let's assume that. Now, one thought that might come in the mind of a parent is, how soon should I encourage my child to explore about this? I know there is no, there is no set recommendation, but what would you say? See, there is no early age or too early for being curious, right? That is not there. But if they were
Correct.
to really bring a more structured approach to their child learning about quantum, what would be your recommendation?
See, you have been in education. We use a phrase in education ever so often called teachable moments. So there are teachable moments across. At any point of time, you can talk about this thing. And the challenge is, where do we get those examples? And that is why whoever are going to be the leaders of change will have to create a repository of such things that parents can use and reuse. Now, I have been very fortunate in being in a family where my father did a lot of such things. So I will share with you, when I was in school and we were being told about geometry simple theorem that three angles of a triangle are two right angles, 180 degrees, and so on. And I come and told my father that I learned this right away. He gave me an example of spherical geometry where the three angles of a triangle are not 180 degrees. The North Pole to equator, equator to equator, there he said it 270 degrees. Right then he explained to me that this theorem is true for plane, but not for curved surfaces. And in curved surfaces, it can be more than 180, it can be less than 180. Later on, it's called Riemannian geometry, spherical geometry, whatever. So the point is, you can leave it at that. You can tell people, everybody, every time that there is a thing that this is the so. So, for example, we use this thing, etc. But in truth, it is this thing. When you know more, it is something else. So you won't believe it. I was introduced to general relativity, the word geodesic. So we had taught the shortest distance between 2 points is a straight line. And at the same time, my father taught me it is a geodesic on a curved surface, etc., etc. And the very interesting example used to be to find the distance between, say, an insect is at one point in a wall and it wants to go to another point on the wall. How would it go? And he would say, you unfold this, make it a flat surface, make a straight line, and take it. So the point is, if you engage children in thinking, they will be able to pick all this up. And in due course, they will learn the serious concepts also. The problem that we often try to give, and this is, I think, the conspiracy which comes from religious times, we don't want people to be knowledgeable in thinking. As a society, we didn't want women to know, women to learn. We kept women ignorant for only recently women have been allowed to. In fact, even when I was in school, I studied in a convent school, the corresponding girls in a convent school were not allowed to study science. They were only supposed to study literature, history, and do courtesy. They were not supposed to put their brains on trying to understand science and so on and so forth. Till as recently as this. So we don't want children who will challenge the status quo, ask questions, want more. I remember that again, one more mystery. So when I was taught Pythagoras theorem in class, I asked the teacher, but is there something where a cubed plus b cubed can be c cubed with a, b, c being integers? And he had no idea because this is Fermat's last theorem and he had never heard of Fermat's last theorem and so on. So and in fact, a very well-known mathematics professor in the US, he calls this concept vertical acceleration. He says, when you have taught a concept, teach it all the way. 1 plus 2 is 3. Yeah. 1 million plus 2 million is 3 million. It's the same concept.
Same concept. Yeah. You don't have to wait for 2-3 grade levels for the child to
from so grade 4 to 5. And then, right. So if 1 plus 2 is 3, then 1 million plus 2 million is 3 million. So the point is that, I have no hesitation in saying, and I can say this in the forum, our purpose of the education system is not to help you in learning, but to come in the way of your learning. And I am willing to have a full session on this whenever you want. No, they don't want you to learn. In fact, I have met so many people, like you must have known those people I know who are very smart, and they're actually being chided by the teacher. आप अपने बच्चे को इतना ज्यादा मत सिखाया करिए, क्लास में बड़ी प्रॉब्लम होती है. I've met this reaction for people. वो बच्चे को ज्यादा इतना मत सिखाइए, क्लास में प्रॉब्लम होती है.
Parenting is not easy, right? You do and then you suffer, you don't do and then you suffer. So that's a very interesting point. And you talked about teachable moments, but I think what is now more important for parents is learnable moments and learnable.
Yeah, same thing. Yeah, exactly.
Throughout, I mean, because parents have to upskill, and now we are lucky we have things like AI or Chat GPT where we can simply use it as an assistant, personal assistant, just asking them questions, getting relevant data.
And you can actually ask Chat GPT as a parent, what should I do to do this? Exactly. See, the beauty with Chat GPT is it allows you to do your role. See, Google is giving you a straight answer from a database.
Yeah.
But Chat GPT, you say, as a parent of a 4-year-old, how do I explain whatever?
Lovely.
So So in fact, I am a great admirer of this whole idea that you can now teach, and this new technology is a tool for the parents. It's also a tool for the children. The child can say, my parent keeps on telling me all kinds of stuff. How do I avoid getting him to do that?
Okay, we're not giving any ideas to children here. This is the parenting. So before we close, I think this has been one of the most insightful conversations I've had. Before we close, this is the Truth and Dare podcast. So we have unpacked this truth that quantum science, quantum learning is here to stay. We have to upskill ourselves, upgrade our own understanding, and use it to actually become better parents. Now, every episode, I urge the speaker to give a dare to the parents. What we've heard you, the parents have heard you. What is it that they can take, one actionable dare that they can take after this podcast episode?
Oh, the response is very simple. Start learning quantum yourself. Because even people who studied science, the way they study, they've been terrified of quantum. So get started and use this exactly thing that why is quantum important? So you can begin with the history. One of the examples I give to people, very simple to try to understand quantum in daily life. I said, you go to your kitchen, switch on the gas comes with a blue flame. You have common salt in your kitchen, pick up some of that salt, sprinkle it on that gas. If you want to, let's say some soda, this, that, whatever you like, sprinkle some salt in. That flame will turn yellow. It's a quantum effect. Because the flame turns yellow because now you're talking of the spectral lines emitted by the sodium spectrum, the same as the sodium lamp on the street.
Yeah.
And that's a quantum phenomenon. You demonstrated quantum phenomenon right there without any equipment, without anything, and so on and so forth. So the point is, because quantum is the truth, it is the thing around you. And in fact, when Richard Feynman encouraged people to make quantum computers in 1984, this is what he said. He said, damn it, nature is quantum. If you want to understand it, you have to make a quantum computer. And the race for quantum computers therefore started in the 1980s. So, and I gave you this example. Do you have nothing more complicated? You have a kitchen, you have that gas flame, it is blue in color, sprinkle some salt on it, it will become yellow. You have demonstrated quantum physics.
Nice. So quantum in everyday life. Lovely. On that note, I think I'm very inspired to actually upskill myself, look at these small things in and around of me, which will bring quantum to life for me. I know quantum is around me, but it's just that my limitations as a human being are not allowing me to see those phenomena. But I can indulge in all of these experiments. And I think the crux of our conversation is let's all become a little more carefree in experimenting and what will go wrong, right? And we don't have to have science backgrounds. Parents, even those who didn't have a science background, can nurture that curiosity later in life. And being a parent is the best way, because now you have a buddy with you who's very, very curious, who's very, very interested in experiments. So you can actually piggyback off of your own child and become a scientist or explorer later in life as well.
Yeah.
Great. On that note, thank you so much. I really appreciate it. I think my parents are going to absolutely love this episode. I'm looking forward to their comments. And just before we leave, where can parents reach out to you if there are any, or if there are any resources, websites, books that, of yours that parents can refer to, please feel free to mention.
See, I am most actively present on LinkedIn nowadays. Every Friday, I post something about quantum. I am on social media. I'm on Facebook also. I'm on LinkedIn. I am on Instagram also. I'm not on TikTok, but but the point is that for me, and I'm very active on WhatsApp. So messaging WhatsApp is most important. I run WhatsApp group on various things. I will probably run a few courses on quantum on WhatsApp and so on and so forth. But feel free to send me a message, mmpant@gmail.com. My Twitter handle is @mmpant. See, I was one of the early adopters, so I could get that name. So Twitter, mmpant, Facebook, mmpant, LinkedIn, mmpant, mmpant@gmail.com. I don't use it now, but mmpant@hotmail.com was also taken. But today I am most active on LinkedIn.
Lovely.
So, and yeah.
And I'll be
See, LinkedIn has the advantage that each piece is about 500 words.
Yes.
So it's readable in a few minutes. And then I give a lot of links for more details. For
Absolutely. And for all the listeners, he is a repository of knowledge, wisdom, information. I refer to so many of the books that he was generous enough to give me. And as you can see, lots of books behind him. So definitely we'll leave all the links for you to connect with him. And thank you, sir. We appreciate your time.
Thank you. Thank you. Thank you.
Focus on this particular issue. Lovely.
Thank you. Thank you.
See you again.
See you.